Hi, this is Kathleen O'Connell, and we are going to talk today about figures. I'm going to cover two different kinds of figures in this talk. One of them is uh, a frequency distribution, which is a kind of figure that where you only have one variable that's shown. And the other kind of distribution are figures or charts that show two variables in the same chart. Okay, so the first one we'll talk about is a bar chart. A bar chart is a chart that is used to display categorical data. I don't know if you can see this very well, but in this example, the categorical data is ice cream flavors, the preferences of 24 people. Okay, so we have along the horizontal axis are the different categories. That axis is called the abscissa. And along the vertical axis, which is also called the ordinate, we have the frequency, the number of people who prefer each type of ice cream flavor. So we have 5 people preferring vanilla, and Rocky Road is the big winner with 6. Peach and black cherry, not so much. Okay, so that's a bar chart used again for categorical data, and it just displays one variable, the display of ice cream flavors. The next figure also just shows one variable. We don't even see the variable that it is because this is something that should be familiar to you. It's the normal curve, or also called the z distribution. So this figure is actually a frequency figure, and if you have enough data for many variables, they fall in a normal distribution. So a normal distribution, as you can see, and what we have in this distribution is the percent of people who fall in each of the subsections of the distribution, and the subsections here are half a standard deviation. So this is where we get the idea that between -1 standard deviation and +1 standard deviation, there's 68% of the subjects should be. That's 19 and 19 are 38, plus 15 and 15 are 30, 30 and 38 are 68. So that's 68% of the distribution. The other thing that, so what's happening here is on the horizontal axis, what you have is the standard deviations from the mean, and they always display the mean as 0 here, so the mean is converted to 0 in these figures, and the standard deviations are arrayed around that mean. Okay, so and then on the vertical axis is actually the number of people, or the number of subjects that are in the distribution. Now the numbers can vary depending on how big your sample is, but if it's a normal distribution, 19% are in between 0 and half a standard deviation, either above or below the mean. So that's how that works. Another thing that you should notice that I've marked on here is 1.96 standard deviations. Now 1.96 standard deviations, if you look at the area, 95% of the subjects. So 95, that's the 95% of this distribution is, and a normal distribution is encompassed between -1.96 and +1.96. Now that number will become useful again when we talk about 95% confidence intervals, which we'll do in another talk.